Today we're going to talk about graphing logarithmic functions. So to graph logarithmic functions, first you want to graph the asymptote, and then graph at least 2 points and sketch a logarithmic curve. You should know by now what an exponential curve looks like. A logarithmic curve just looks like the inverse of it. It does have the asymptote is always going to be a vertical asymptote. And the 2 points, sometimes there are easy points to pick, and sometimes you'll just have to plug in numbers that are in the domain. Hopefully you remember these basic facts about logarithms, but I'll remind you. What is the domain of log base b of x? Well, you can't take the log of a negative number. You can't take the log of 0, but you can take the log of a positive number. So whenever you substitute something in, it has to be greater than 0. So this will help us in finding our asymptote. We'll set everything inside the logarithm equal to 0, and that'll be our asymptote because the input has to always be bigger than 0. Log base b of 1, well, that's the same thing as log base b of b to the 0th, because b to the 0th is 1, so this is the same thing as 0. Also, if we have log base b of b, that's log base b of b to the first, which is 1. So when we plug in 1, we get out 0, and when we plug in b, we get out 1. So these are going to be 2 easy points for us to substitute in when we're graphing the simple log functions. So first, we'll graph x equals 0 as the asymptote. Then we graph 2 points and sketch a logarithmic curve. Now specifically, this is for functions that look like log base b of x, can't have any addition or subtraction in there, or even multiplication or division. So, 2 straightforward examples. If we have this, first we're going to graph x equals 0 as our asymptote. Blue feels like a good color for this. So that's supposed to be x equals 0. And then we graph our 2 points. 1, 0 is on every untransformed logarithmic function. And then we go to 5, 1. And because there's no addition, subtraction, multiplication, we can just say that this is a good representation of it. And if you tilt your head to the side, you'll see that this looks like an exponential decay function, which should make sense. Natural log of x. So once again, we have an asymptote at x equals 0. When we plug in 0, we should get out, when we plug in 1, we should get out 0, so 1, 0 is a point. And then if we go over to e, which is 2.718, that'll be 1 as our output. So this will look like this. It's a little sloppy, but that's approximately what the natural log of x looks like. So what happens when we have to do something besides just natural log of x, when we have to do natural log of x plus 3 or something like that? Well, generally you'll graph the asymptote, then graph at least 2 points, and sketch a logarithmic curve. So the asymptote, the way we'll find that is by setting the input, and I don't mean x, equal to 0. So whatever, if we have log base something of that, that's what I mean. Everything that's inside the parentheses of the log. Then we graph at least 2 points. Sometimes you can figure out some easy points to graph, but sometimes you'll have to guess around at some things and maybe estimate using what you know about logarithms. And then you'll sketch a logarithmic curve. That's the easy part. So let's say we have log base 6 of x minus 1 plus 2. So the first thing is to say, all right, we want to find the asymptote. We'll take the inside and set it equal to 0. So that's going to be our asymptote, x equals 1. Now that we have our asymptote, we need to plug in points. Now, based on this asymptote and the fact that this is x minus 1, we know that this has been shifted to the right. So I shouldn't plug in any negative numbers or 0 or decimals between 0 and 1. I should plug in numbers over here. 2 seems like a promising number to plug in because 2 minus 1 gives us 1, and we know what that is. So f of 2 equals log base 6 of 2 minus 1 plus 2, log base 6 of 1 plus 2. So that's log base 6 of 1. One of our log rules is that that is automatically 0, so this is 2. So 1 comma 2, no, 2 comma 2, 2 comma 2, that's the coordinate. So we input 2, we output 2, so 2 comma 2 is a good point. Now another thing to try is to figure out a way to make this whole thing equal to 6. So if x minus 1 equals 6, then we'll be able to get something like log base 6 of 6. So x equals 7 is a good number to try. If I plug in f of 7, I get log base 6 of 7 minus 1 plus 2, log base 6 of 6, 1 plus 2 is 3. So f of 7 is 3. So now we have our logarithmic curve. Now you'll notice that this has a slope of 1/6, which is closely related to this 6. This is all, you can also think of this as transforming this right 1 and up 2. If you had plugged in something like 4, you would have gotten out a decimal between 2 and 3, and that's fine. You just need to know to graph that and then sketch the graph. But I picked a number that would make this easy. Specifically, I looked at the input, tried to make it equal to the base. Some more examples. For the asymptote, we should set the whole thing equal to 0. And by the whole thing, I mean the input to the log. So 4x equals negative 12, x equals negative 3 is our asymptote. Now, what do we want to plug in? Now, you can go a number of different routes. One is to say, okay, the domain includes 0, so 0 is a good number to plug in. So we could say this. Or you could do other things. So log base 3 of 12. Well, it's somewhere between log base 3 of 9, which would be 2, log base 3 of 27, which would be 3. So I'm going to say that this is approximately 2.2 minus 2. So this is about 0.2. So 0 comma 0.2 seems like a good estimate of where that would be. What else do I want to try plugging in? Let's try making this input 3. If I say 4x plus 12 is 3, then that's saying 4x equals negative 9, x equals negative 2.25, or 2 1/4. If I plug that in, I'll get f of 3, f of negative 2.25. I want to plug that in. Why am I plugging that in? Because when I plug that in, we know that this 4x plus 12 will be 3. So then we get log base 3 of 3. Well, log base 3 of 3 is just 1. Minus 2 is negative 1. So when we plug in negative 2.25, we get out negative 1. And now we're getting the curve. Sorry about that. I don't know what just happened. And then one more. Let's see. Start with the asymptote. So at 1/2 we have an asymptote. Then let's see. If we got this whole input to be 1, that would be nice. So what would make this whole input 1? Oh, lucky us. If we plug in 1, we'll get out 1 as our input. So we'll have log base 2 of 1 plus 1 is 0 plus 1 or 1. So in other words, what I just did is I tried to figure out what would make this 1, because that would be 0 as the output of log base 2. And then we add 1 to that, so that's 1 comma 1. Again, these are tricks that I'm using to try to figure out easy numbers to plug in. You can certainly plug in whatever numbers that you want as long as they're in the domain, and they'll give you points that you can use. But I'm going to try these easier ones. What if this were 2? If I'm going to try to make this equal to the base. So 2x equals 3, x equals 1.5. So when I do log base 2 of 2 times 1.5 minus 1 plus 1, log base 2 of 3 minus 1, which is 2. So that's 1 plus 1, or 2. So when I plug in 1.5, I get out 2. So that gives me a good sense of where this is going. I want to have a better idea of what this is going to look like, though, so I'm going to plug in a larger number. Let me plug in something that will work out well for us. Let me plug in 4.5. Why would I plug in 4.5? Well, if I plugged in 4, this would be 8 minus 1 is 7. But if I plug in 4.5, then this will be 9 minus 1. And that's 8. Why do I care about it being 8? Well, because we're talking about log base 2. If this were log base 3, I'd love for it to be 9. So this is 9 minus 1, which is 8. Log base 2 of 8, hopefully you know by now that is 3 plus 1, so 4. When we plug in 4.5, we get out 4. So now I'm getting a much better sense of what this logarithmic curve is going to look like. And that's what it's. There is my graph. So this is how we graph our logarithmic functions. First, find the asymptote by setting an input equals 0. Graph at least 2 points. As a reminder, it's helpful to use points where that are our fundamental points. When we plug in 1 as our entire input, then that makes our lives easy. When we plug in b as our entire input, that also makes our lives easy. And then once we've finished that, sketch our logarithmic curve. Thanks.